No, not yet. I'm just going to do like a really quick, for those that aren't here, how you do this. And I kind of talked about this. So y'all listen if you haven't been doing this. If x is in the exponent, it's exponential. So you would circle yes, exponential. Like a on this one, x is in the exponent. Yes, it's exponential. Any of those with x in the exponent, yes, exponential. There's one that's quadratic and one that's linear. So you would say no, it's quadratic if it has a square. And you would say no, it's linear. You should know which one of those is going to look like a straight line. All the rest on this are exponential. So again, you just put yes, exponential, or you put no, and the reason why is it's either quadratic or linear. Only two of them are no. Now, when you get to this one, and I know I'm going quick, you just graph them. I would just pick two different colors. I would graph, let's say, A in purple and B in another color, okay? The domain on these is all real numbers because you can go left and right forever and ever and ever and ever, okay? So on example 2, your domain, all real numbers, all real numbers. Let me graph it real quick. Now, you'll have to put it on your paper, but I think everybody knows how to go to your table and graph this on your paper. Now, you can see x can go left and right forever and ever and ever. I can keep plugging in different numbers for x. You'll notice something about our y values. Our y values never go above what? Never go below what number? 0. So that's why your range on this one, for your range, you're going to put y is greater than 0. Okay? If it went this way, it would be y is less than 0. That's a y is greater than 0. Do you see that? Because you don't go above or below those. So that's what range means. And again, your domain is going to be all real numbers. Okay? So the range just tells you, oh, you're above this or below this. Greater than is the above, less than is the below. So it's like y is greater than 0. Okay, I know I'm flying through this. All right, on this one, all they want you to do is graph this function here, right here. So you know it's moved to the left 3 and down 1 and it's flipped without even graphing it. But plug it in on here, okay? So real quick, if I do that, -2 to the x plus 3, put all that in parentheses, -1, you'll see it's moved to the left, okay? It's gone down 1 and it flipped over. You would graph this right here using your table, second graph. But y'all all know how to do that. Those are huge numbers. Go this way. There's numbers you can deal with. Okay, so here's your graph. Your domain, again, is all real numbers. It's going to be all real numbers. But your range, what is it going to be on this one? Does anybody know? Is it greater than or less than, first of all? What are our y values? Our y values are less than what number? -1. Okay, so you would put for your range, y is less than -1. Your asymptote, we haven't learned that yet, but it's just that line right here. Where does it not come to? This line right here is an asymptote. So you would put y equals -1 is the equation of your asymptote. Okay, we will learn that next year a lot more. Okay, so I flew through those. Then I think y'all can just do example 4. All you have to do is plug that one in and graph it, plug that one in and graph it, plug that one in and graph it. Right here, I would just use a different color, okay? That's for each of them. That's all you're doing on that is graphing it. Okay, then on this page, you're just graphing them and matching them. You don't even have to me, you don't have to graph it. You can just see which ones are positive, going up, which ones are negative, going down, right? But all you're doing is just plug them in your calculator if you want and match them to whichever graph. If you're gone to Mississippi, you don't have a calculator, Desmos works. Just throwing that for those. Okay, then Desmos, that's a graphing calculator on the computer. So if you have a computer or a phone, you can go to desmos.com, hit graphing calculator, and it will it'll graph for you. But I don't know if you can get a table of values. I'm not really sure. Okay, can I keep going? And I know I'm flying through this. Okay, On these, you can tell if it's growth or decay, right?
On number 8?
On number 8, 7, yeah, any of them.
What's
Number
number 8?
8, is this number between 0 and 1, or is it bigger? Just look at the 4.
Yeah, it's bigger.
So it's growth. Okay? And then you're just saying where it's moved. This little box right here is nothing. Okay, it was actually a mistake on all these. It's like, it looks like a table. You can use it for a table of values, but you don't have to. But you're doing the same thing on these. You're just saying you can underline growth or decay, where it's moved. You know, like left or right or up or down. Your domain, all real numbers. Domain, all real numbers. You know, y'all don't have to do the ordered pairs because that's what, if you do the table, right? This is the same. No, like if you write them in the table right here, that's not really supposed to even be there, then you don't have to do the ordered pairs. That just means like, what are ordered pairs on your graph over here? And then you've already done range. You'll just say y is greater than something or y is less than something. You just have to figure out where that line is. And that's what your asymptote. Your asymptote is that line, y equals. Domain is all real on these, okay? And then your range is either y is less than or y is greater than. You would have to pick and what it is. And you'll do that for 7, 8, all those through 12.
What do you do for
Transformation, like on number 7, where has it moved? It has moved to the left 2. Where else? Down 1. And then if you say anything about the 3, you can say stretched by 3. Okay?
So like number 8 is to the right,
To the, yep, left 1. Then what? Up 3. Flipped.
That's all I can say is up and up 3.
And then it's flipped or reflected because of the negative sign, right? Yeah.
So is the range on number 8 y is
Let me graph it real quick. Let's see if
less than 3 or greater than 3?
-4 to the x plus 1. Okay, this is what I get on that graph when I entered that in my calculator. And you said, is the range what? It's y is less than something. What number is it less than? It's got to be 3. Yeah, so you're going to say y is less than 3 is the range of that. And what's your asymptote? Y equals 3.
This is on number 8 or 7?
This is number 8. This is number 8. So I graphed it. If you graph it, and you can tell that our graph is, it never goes above this line. That line, y equals 3, that is your asymptote. Again, this is number 8. And then your range, it's the same thing as the asymptote. It's y is less than 3 because you're staying less than that asymptote. Okay? And then the rest of them are kind of the same way. So I hope that helps. Does that help get y'all through this? We've learned it all. It's just kind of, we added domain and range. A good review.